Welcome to All This Math. This is Professor Parker, and today I do want to give a shout out to the late David P. Richardson. He was a black politician out of Philadelphia, a youth organizer many years before that. He was essential in organizing the Philadelphia high school student walkout back in 1967, where black students in Philly were organized and were advocating for themselves and making demands on the school district of Philadelphia for things such as black studies, more black teachers, more black administrators, and things of that nature. So that's why I'm rocking the sweatshirt today. This is a picture of David P. Richardson. All right. Now, let's jump into our lesson. So, today's lesson, we're going to talk about simplifying radicals. All right. Now, first off, let's talk about some terminology. What is a radical? A radical is this symbol right here that looks like a long division sign, except it's got this little check on it at the end, right? So radical sign, and then I want to talk about what a radicand is. Radicand. Let me write that down. So a radicand, Radicand, because I don't want to just be throwing terms around it that you don't understand or you're not familiar with. I'm going to put you on, right? The radicand is the term or terms or information that's inside of the radical sign. Think of the radical sign as a house. And when I get into my explanation, I'm going to use an analogy. I'm using an analogy of the house, the radical sign as a house. And it'll make more sense when I get into my explanation. All right. So now, also, because there's no number written right here, it's assumed that there will be a 2 right here. So that's how I know I'm looking for the square root or the second root. The square root or the second root, because there's no number written right here. This will be called your index. The number that will be written in here. And because if there is no number written in there, it's assumed that it would just be 2. All right. Now, there could be a 3 in there. If you ever see a 3 in there, then that means you're looking for the third root or the cube root. If there's a 4 in there, you're looking for the fourth root. All right. Now, what is this radical sign telling us to do? As with most math problems, like I'm saying, like with most math problems, let me try that again. Every math problem is a set of instructions. We're being told what to do, right? This radical sign is a set of instructions. It's telling me to find out what the square root of this number is. So what the square root of 25 is. Now, that's also something we need to understand. What is a square root? A square root is a number, a whole number, or an integer that can be multiplied by itself and will equal that number, right? No, let me back up, because that's not 100% correct. Every number has a square root. A square root doesn't have to be a whole number or an integer, right? It doesn't have to be. A square root could be a decimal. Now, what I was thinking about actually was a perfect square. A perfect square, right? A perfect square is a number that has a factor that can be multiplied by itself, meaning the number is multiplied by the same number and it results in that number. All right? That might have sounded a little confusing. Let me try to break it down using this example. So 25. 25 has a couple factors, 25, 1, and 5. 5 is a factor because 5 times 5 equals 25, right? So that means 25 is a perfect square because it has a factor that can be multiplied by itself, and the factor is a whole number. That's the key. That's the key element. The factor has to be a whole number, right? That can be multiplied by itself to equal that number. So let's think of some other perfect squares. 36 is a perfect square because 6 times 6 equals 36. 49 is a perfect square because 7 times 7 equals 49. 100 is a perfect square because 10 times 10 equals 100. Notice how I'm only dealing with whole numbers. No decimals, no fractions, none of that, right? But 17 is not a perfect square because there's no whole number factor that can be multiplied by itself to equal 17. Many numbers can be multiplied together to equal 17, but none of them are going to be whole numbers, right? Not multiplied by themselves, right? I mean, the square root of 17 is like 4 point something. 4.1 maybe, 4.1, 4.2, probably around 4.1, right? 16 is a perfect square because 4 times 4 equals 16. All right, so now let's get back to number one. Number one is telling me to take the square root, because I see this symbol with no number written there. It's telling me to take the square root of 25. So it's asking me what number multiplied by itself would equal 25. And I know because I know my multiplication facts. I know that 5 times 5 equals 25. And I just want to advocate, I want to take a moment to advocate and encourage everybody watching this video to memorize your multiplication facts. Do yourself a favor. No matter how young you are, no matter how old you are, memorize your multiplication facts, at least from 1 to 15, well, at least from 1 to 12, but I say 1 to 15. You can go to the allthismath.com website, and we have printable forms, printable multiplication table templates right on the website that you can click on, you can print, right? Absolutely free, won't cost you nothing but the paper and your printer and a little bit of your toner or a little bit of your ink, whatever, right? That's all it's going to cost you, all right? It's not going, you don't got to pay for it. It's there. I want people to have it because I want our people to know their multiplication facts, right? We need to know our multiplication facts. We need to know that 5 times 5 is 25 off the top without pulling out a calculator. We need to know that 8 times 8 is 64 off the dome without pulling out any calculators. We need to just know that, right? That should be just common knowledge in our community, okay? So the square root of 25 is 5. I know that because I know my multiplication facts, and I know that 5 times 5 equals 25. So therefore, 5 is the answer to number 1. All right, now this way it starts to get fun with problems like number 2 and number 3. All right, pay careful attention because I'm about to break this down too. Now, number 2 is telling me to take the square root of 48. Now, the first question you should always ask yourself when you see a square root symbol is this: is this a perfect square? Is this a perfect square? Right? Is this a perfect square? So is 48 a perfect square? That's your first question you got to ask yourself. You got to say, is 48 a perfect square? We say no, again, because we know our multiplication facts. When you know your multiplication facts, then you know, okay, well, is there a number on the multiplication table, a whole number that can be multiplied by itself that equals 48? There is none. There is no number, right? There are numbers that can be multiplied together to equal 48, but none of them will be, there's no number that can be multiplied, no whole number that can be multiplied by itself to equal 48. When you encounter that situation, the next question you got to ask yourself is there a factor of the radicand that is a perfect square? Is there a factor of the radicand that is a perfect square? So 48 is the radicand, right? And we want to know, does 48 have a factor that is a perfect square, right? And then it gets a little more detailed because I know that 4 is a factor of 48 because 4 times 12 equals 48. And I know that 4 is a perfect square. But let me add this to the mix. You want to pick the biggest perfect square factor, not just any random perfect square factor. You want to pick the biggest one, right? Now, 1 is also a perfect square, and 1 is a factor of everything. But 1 doesn't help us in this process. So put that in your notes too. 1 as a factor does not help us in this process, and you'll see why in a minute. But anyway, 4 times 12 is 48. But that's not the biggest, though. And again, I know my multiplication facts, right? I got familiarity with numbers, so I know that 4 is not the biggest. I keep thinking about other factors of 48, and I happen to know that 48 is also equal to 16 times 3. And this is the process that you got to go through. If this radicand is not a perfect square, you got to think about, okay, what are the factors of this radicand? What are they? What are their factors? What are the factors of this radicand, right? That's what you want to think about. What are the factors of the radicand? And what's the biggest one that is a perfect square? Or does it have one that's a perfect square? Because not every number has a perfect square factor. It just so happens that 48 does. So we can rock out and simplify this in a certain kind of way. Now, since I know that 48 can be broken down or factored into 16 times 3, I'm going to rewrite this with the radical sign, and it becomes 16 times 3. All right? Notice how this is equivalent to this. 48 is 16 times 3. They are the same thing. All right? Now, what I can do now, just like up here, 25 was a perfect square. So think about it like this. If you think of the radical sign as a house, the 25 was able to come out the house because it was perfect. It was a perfect square. All right? So it was able to come out the house. So only perfect numbers can come out the house. Think about it like that. That's a way to remember what the steps in the process are. So now I got two numbers in the house, because remember, I'm thinking of my radical sign as a house. Only perfect squares or perfect numbers can come out. 16 is a perfect square. So 16 can come out based on my logic, right? But when it comes out, you actually take the square root of it. So again, you're taking the number that can be the whole number that can be multiplied by itself to equal 16, which is 4, right? So 16 comes out and now it's a 4. The 3 is not perfect. 3 is not a perfect square. There's no whole number that can be multiplied by itself to equal 3. So 3 has to stay in the house. 3 can't come outside. 3 got to chill inside the house. Can't come outside. So now I got the 4 outside. I'm not going to write it on top of the radical sign. I'm going to write it next to the radical sign. And I got 4 root 3. And that's my final answer for that. So for number 2, I got 4 root 3, or 4 times the square root of 3. All right? So just remember, when you see a question like this, if the radicand is not a perfect square, the next question you ask yourself is, okay, is there a factor of that radicand or a factor of that number that is a perfect square? Then when you start thinking about that, then you think, okay, well, is this the biggest perfect square factor? Because I don't want just any perfect square factor. I want the biggest perfect square factor. Like, I don't want to use 4. I want to use 16. Now, in case you're wondering why that is, it's because if I don't use the biggest, I'm going to have to do this step again, right? Because this is what would have happened if I'd have used 4 times 12. If I'd have broke 48 down into 4 times 12, the 4 is perfect, so the 4 is going to come out. It would have turned into a 2. But then I still got a 12 inside of here. The 12 can be broken down. Because 12 is not a perfect square, but 12 can be broken down, just like 48 was broken down. So then I'm going to have to do that same step over again. If you pick the biggest perfect square, then you only got to do this step one time. So why would you do a step twice when you can do it just once and get it out the way and be done? Think about that. Always pick the biggest perfect square factor, right? Not just any perfect square factor, but the biggest. All right, so that's done. Now, when you get down to number 3, things get a little more funky because look, we got variables in here, right? We got variables with their own exponents, all right? So now, when you see a problem like this, what you want to do is, okay, you see there's a radical sign, right? There's no number right here. There's no index written right here. So we're taking the square root. We're looking for the square root, right? All right, so now we got to break this down into 3 parts because we got a 12 here, we got an x to the 6th here, and we got y to the 3rd here. All right, so now I know I could break 12 down, right? And I'm going to break 12 down like this. 12 is going to become 4 times 3. Because you got to think, okay, does 12 have 12 is not a perfect square. We know that because there's no whole number that can multiply by itself to equal 12. So 12 is not a perfect square. But can I break 12 down in a way where one of the factors is a perfect square? Yeah. I break 12 down into 4 times 3. And 4 is a perfect square. So eventually 4 is going to come out. And when it comes out, it's going to turn into a 2. The 3 is going to have to stay inside. But what about this x and this y, though? What you going to do with that? Well, there's a piece of information that you need to understand about variables with exponents. Really, any term that has an even-numbered exponent is a perfect square. Put that in your notes. Any term that has an even-numbered exponent is a perfect square. Now, how would you actually take the square root of that term? All you do is you divide the exponent by 2. That's all you do. You divide the exponent by 2. If it's a perfect square, you divide the exponent by 2. I'm going to get into another lesson in another video at another time about rational exponents, which is going to make this make a lot more sense. But for now, just understand, any term with an even numbered exponent. So x to the 6th is a perfect square. X to the 10th is a perfect square. X to the 20th is a perfect square. X to the 50th, x to the 248th power is a perfect square. Any term, whether it be a number or a variable, with an even numbered exponent is a perfect square. So x to the 6 is perfect. Now, how do I take the square root? All I do is I take half of the exponent. So what's half of 6? That's 3. So this x to the 6th, think about it like this. If I had x to the 6th, x to the 6th would come out and turn into x to the 3rd. So the x to the 6th is going to come out because it's perfect. So it comes out, but you take half of the exponent. It's going to be x to the 3rd. Now, this right here, y to the 3rd. Now notice, or remember, I told you, any term with an even numbered exponent is a perfect square. 3 is not an even number. So what can I do? I got to break this down. I'm going to show you another trick. Whenever you see an odd numbered exponent, you could break that down if you remember your exponent rules for multiplication. I could break this down into y squared times y to the 1st. Remember from the exponent rules, if I want to multiply y squared times y to the 1st, don't I just add the exponents together? And I would do 2 plus 1, right? Which would equal 3. So y to the 3rd is the same thing as y squared times y to the 1st. And you don't have to write this one. I just wrote it here for emphasis for the video, right? So you can really visualize what's going on. Now, why did I do this? When you're doing math, you should always know why you're doing it. Know why. Not just know the process, but know why the process is what it is. Know why you're doing what you're doing, right? So now, I did this so that I would have y broken, a piece of y to the 3rd would be a perfect square. Because remember, I told you, just like with x to the 6th, any term, variable or number, with an even numbered exponent is a perfect square. And all the perfect squares can come out the house. Because basically, when you see a problem like this, you're trying to either get rid of the radical sign or get everything that can come out of the radical sign to come out. That's what you're trying to do. At the end of the day, that's your goal. You want to get everything out that can possibly come out. So now what's going to happen is I could pull this y squared out. And when I pull it out, remember I also told you, all you got to do is divide the exponent by 2. So what's 2 divided by 2? 1. So this is going to be y, or y to the 1st, right? Then you ask yourself, okay, the 4 came out, turned into a 2, because 4 is a perfect square. The x to the 6 came out and turned to x to the 3rd, because x to the 6 is a perfect square. Any term with an even numbered exponent is a perfect square. And when you take it out, all you do is divide by 2 in the exponents, and that's your square root. Then I broke y to the 3rd down into these two parts, these two pieces, y squared and y to the 1st. And let's say you had like y to the 29th power. Y to the 29th would be y to the 28th times y to the 1st. Y to the 57th power, y to the 56th times y to the 1st. And so on and so forth, right? That's just something for you to memorize. All right, so the y squared comes out and turns into a y. Now, I'm going to just clean this up and write the final answer. There's a 2 outside. There's an x to the 3rd outside. There's a y outside. Now, there's still a couple things inside the house. This 3 is still in the house, and this y is still in the house. So 3 had to stay, and y had to stay. They got to keep each other company inside the house because they can't come out because they're not perfect. All right, but this right here is the final answer.